46 million homes. 1 in 3 American homes is now in a fire zone. This is a threat assessment most homeowners. Four minutes.
This is the sky over Los Angeles, January 7th, 2025. The glow on the horizon is not the sunset, it's the beginning. The Palisades Fire moved faster than anyone predicted. Pushed by 70-mile-per-hour Santa Ana winds, it covered a mile in under 30 minutes. And the embers arrived first. By 11 p.m., entire blocks were gone. Not burning, gone. House after house after house. Wood frame. Every single one. This house went from first ember to fully engulfed in 3 minutes and 47 seconds. Not 4 hours, not 40 minutes, 3 minutes and 47 seconds. By morning, 12,000 structures were gone. 12,000. Foundations and chimneys. That's all that was left. 29 people dead. $30 billion in damage. 72 hours. And every single house that burned shared one thing in common. Every house was wood frame. Every one. And I need you to understand what that means. Because the fire didn't destroy what was weak. It destroyed what was normal. What was standard. What was everywhere. This is the engineering story nobody told you. And it starts with a question no one wants to answer. How long does a normal American house last in a fire? From the air, you see the pattern. The fire didn't skip houses randomly. It took everything, block after block after block. And when you look at what's left, you see something specific. Concrete survived. Brick survived. Stone survived. Everything made of wood. The framing, the siding, the roof sheathing, the interior walls. Everything wood is gone. The chimney is still here. The house is not. That's not random destruction. That's material selection speaking. The fire is telling you exactly what failed and exactly what didn't. A standard American house. 90% of new homes built in the United States are wood frame. The walls are wood. The roof structure is wood. The sheathing is wood. The framing is wood. You are living inside a fuel source. For 75 years, 9 out of 10 single-family homes in America have been built the same way. Wood frame. The percentage hasn't changed. The fire risk has. But the fire map isn't the same. Every decade, the fires get bigger. They reach further. They burn into neighborhoods that never imagined they were at risk. The houses haven't changed. The threat has. And here is what most people don't understand about wildfire. The fire front, the wall of flames, is not the primary killer of houses. This is embers. Embers travel up to 1 mile ahead of the fire front. 1 mile. They land on your roof, in your gutters, against your siding, inside your attic vents. The fire hasn't reached your street yet, and your house is already on fire. Ember attack is the #1 cause of structure ignition in wildfire. A house doesn't burn because the fire reaches it. A house burns because it has openings, gaps, vents, eaves, gutters full of leaves. Every gap is a door, and embers find every door. This is what happens when an ember reaches a wood frame wall. Minute 0, the ember contacts the siding. Minute 1, the siding ignites. The flame climbs vertically. Minute 2, the fire enters the wall cavity, the space between the exterior siding and the interior drywall. Now the fire is inside the wall. You can't see it. You can't reach it. Minute 4, Structural failure. The wall collapses. 4 minutes. From the first ember to total structural involvement. 4 minutes. That's not a house that's hard to save. That's a house that was never designed to resist fire in the first place. 4 minutes. Say it out loud. 4 minutes. That's less time than it takes to make coffee. That's less time than it takes to load your car. Every standard wood frame house in America, your house, your parents' house, your neighbor's house, is a 4-minute house. Every year, we build approximately 1 million new homes in the United States. 900,000 of them are wood frame. 900,000 new 4-minute houses. Every single year. Every one of these foundations had a family inside it the day before. Every one of these driveways led somewhere. 4 minutes. That's what separated a home from a foundation. I keep coming back to this concrete. It survived. Everything attached to it didn't. And I keep asking myself, if we know concrete survives fire, if we know brick survives fire, if we know steel survives fire, why do we keep building with the one material that doesn't? The answer is 190 years old. Balloon frame construction was invented in the 1830s. Cheap lumber, simple assembly, no skilled labor required. It built Chicago. It built the suburbs. It built America. And we never stopped using it. The cost difference between a wood frame house and an insulated concrete form house is 10 to 15%. For a $300,000 house, that's $30,000 to $45,000 more. That's the price of surviving a fire versus burning in 4 minutes, 10 to 15%. That's the engineering gap between a house that survives and a house that disappears. And the market chose the one that disappears. Every year, for 75 years, 900,000 times a year. If this investigation is making you think differently about what you live in, subscribe. We investigate one structural failure every week, and this one isn't over yet. Because the Palisades wasn't the first warning. It wasn't even the worst. To understand why nobody was ready for January 7th, you have to go back to November 8th, 2018, to a town called Paradise, California. Population 26,000. A retirement community in the Sierra Nevada foothills. Pine trees in every yard. One main road in, one main road out. A town built inside its own fuel. November 8th, 2018. 6:15 in the morning. A faulty transmission line sparks in dry brush near Pulga, California. Wind gusts to 50 miles per hour. Humidity is 23%. The fire starts moving. The campfire moved at 80 football fields per minute. By 9 a.m., less than 3 hours after ignition, the town of Paradise was fully involved. Fully, the entire town. 26,000 people. One road out, bumper to bumper, embers falling like rain, trees falling across the only escape route. This is what an evacuation looks like when a town was never designed to be evacuated. 85 people died. 18,804 structures were destroyed. And look at this. Look carefully. Some of the trees are still standing. The forest survived. The town didn't. The trees survived. The houses didn't. Think about that. The tree, the supposed source of the danger, is standing. The house, the supposed place of safety, is a slab. The fire burned the town because the town was more flammable than the forest. 85 people. 85 people who trusted that their houses would protect them. Their houses burned in minutes. Wood frame. Everyone. Oakland, 91. Cedar, 03. Tubbs, 17. Paradise, 18. Marshall, 21. Palisades and Eaton, 25. The numbers are getting bigger. The fires are getting closer, and the houses are exactly the same. And Palisades wasn't alone. The Eaton Fire burned at the same time. 9,400 structures, 17 dead. In 1 week in January 2025, over 21,000 structures were destroyed in Los Angeles County. All wood frame, all 4-minute houses. Here is the map that should be hanging in every homeowner's kitchen. The Wildland-Urban Interface, the WUI. These are the zones where developed land meets wildland vegetation, where houses meet fuel. 46 million American homes are in this zone right now. 1 in 3. 1 in 3 American homes is in the Wildland-Urban Interface. 1 in 3. That's not a California problem. That's not a rural problem. That's an American problem. Look at the map. Colorado, Texas, Florida, Oregon, Montana. These aren't cabins in the woods. These are suburbs. These are neighborhoods with HOAs and school districts and Starbucks. And they're in the fire zone. December 30th, 2021. Marshall Fire, Colorado. Snow on the ground. And 1,084 homes burned in a suburb with snow on the ground. This wasn't a forest fire. This was a grass fire driven by 100-mile-per-hour winds through a subdivision with a Costco. Marshall Fire proved something that fire scientists had been warning about for 20 years. The WUI fire isn't a rural problem anymore. It's a suburban problem. If your house is wood frame and the wind blows embers at it, it doesn't matter if you're in a forest or next to a shopping mall. The physics is identical. Paradise was in a forest. Marshall was in a suburb. Palisades was in one of the wealthiest neighborhoods in America. The zip code changed. The construction didn't. The result didn't. And here is where the anger starts. Because California actually has a building code for wildfire. It's called Chapter 7A. Materials and construction methods for exterior wildfire exposure. It's been on the books since 2008. Chapter 7A requires fire-resistant roofing, enclosed eaves, ember-resistant vents, non-combustible exterior walls in designated zones, tempered glass. It addresses every major vulnerability. It's one of the most comprehensive wildfire building codes in the world. There's a line in the code that changes everything. Applies to new construction. New, not existing. Not retrofitted. New. The Palisades neighborhood that burned was built primarily in the 1950s and 60s. Not a single house in the hardest hit blocks was built after 2008. Not one. The code that could have saved every house in the Palisades existed since 2008. It applied only to houses built after 2008. Every house that burned was older. The code existed. And it was irrelevant. 17 years. The code sat there for 17 years. And in 17 years, no one required existing homeowners in fire zones to bring their homes up to standard. Not California. Not the cities. Not the insurance companies. Nobody. Homes built to Chapter 7A standards survive wildfire at rates above 80%. Homes not built to those standards survive at rates below 5%. The same fire, the same wind, the same embers. The difference is the code. And the code only protects new houses. $3.2 million. Built in 1962. No fire-resistant siding. No ember-resistant vents. No tempered glass. Standard wood frame construction from the Kennedy administration. And it burned in 4 minutes like a $60,000 house would. And the insurance companies knew. They knew before anyone else. State Farm. Allstate. Farmers. One by one, major insurers have been pulling out of California fire zones. They stopped covering wood frame homes in high-risk areas. They ran the numbers. And they left. If your insurance company won't cover your house, what does that tell you? Insurance companies don't have opinions, they have math. And the math says your wood frame house in a fire zone is not a question of if. It's a question of when. Imagine getting this letter. Your insurance company, the one your family has been with for 20 years, tells you they will not renew your policy. They won't cover your house anymore. You still owe $200,000 on the mortgage. And now nobody will insure it. California's FAIR Plan, the insurer of last resort, charges 5 to 10 times more than standard coverage, and it covers less. The safety net exists, but it's made of the same material as the houses. It's not built to hold the weight. I spent 3 weeks asking the same question. Did anyone get this right? Is there a country, a system, a building code that actually works? And I found one. 12,000 miles away. Australia, a country that burns as fiercely as California. Eucalyptus forests, hot, dry winds, suburbs built into bushland. The landscape is almost identical. The outcome is completely different. February 7th, 2009, Black Saturday, Victoria, Australia. 173 people died. 2,029 homes were destroyed. It was Australia's deadliest bushfire, and it was Australia's breaking point. Australia didn't just investigate. Australia didn't just write a report. Australia rewrote the entire building standard. And the critical word, the word that separates Australia from California, is all, not new construction. All construction, the BAL system, Bushfire Attack Level, 6 levels of fire risk, each with specific construction requirements. BAL 12.5 requires basic ember protection. BAL 29 requires non-combustible exteriors. BAL 40 requires full fire-resistant construction. BAL-FZ, Flame Zone, requires what is essentially a concrete bunker with steel shutters. Every property in a bushfire-prone area of Australia gets a BAL rating. Not voluntary, not recommended, mandatory. The rating determines exactly what materials and methods you must use. And if you don't comply, you don't get a building permit. Period. Same climate, same fire risk, same eucalyptus and pine interface. On the left, an Australian home built to BAL standards. On the right, a standard American wood frame home. One is designed to survive. The other is designed to be affordable. Both countries made a choice. They made different ones. The result: Australian homes built to BAL standards survive bushfires at rates above 80%. American wood frame homes in the same conditions survive at rates below 5%. 80 versus 5. That's not a policy difference. That's a survival difference. This home survived. Not because the fire missed it. Not because firefighters saved it, because every window was tempered. Every vent was ember-proof. Every wall was non-combustible. The fire hit it. The fire lost. Australia lost 173 people on Black Saturday, and they said, never again. They didn't study the problem for another decade. They didn't apply the code to new construction only. They changed the rules for everyone, and it worked. Australia rewrote its entire standard within 2 years of Black Saturday. California lost 85 people in Paradise in 2018, and still, 7 years later, has no mandatory retrofit program for existing homes in fire zones. 7 years. What comes next is the part I needed you to see. Because everything I've shown you so far, the 4-minute house, the ignored code, the insurance exodus, everything changes with what I'm about to show you. And it costs less than you think. In the Palisades burn zone, a few houses survived. Not many, but enough to study. And everyone that survived shared the same features: non-combustible siding, metal or tile roof, tempered windows, and clearance, a buffer zone between the house and any vegetation. Look at the evidence. The siding is fiber cement. It charred on the surface but didn't ignite. The roof is metal. It conducted heat but didn't burn. The windows are tempered. They held at 900 degrees when standard glass would have failed at 500. The attic vent, 1/8 inch mesh, blocked every ember. This house survived because someone chose different materials. Standard window glass fails at 500 degrees. It cracks. It falls out. And the moment the glass falls, the house has an opening. Embers pour in. The interior ignites. The house is lost from the inside. Tempered glass holds to 900 degrees. Same frame, same window, different glass. The house stays sealed. The embers stay outside. A standard attic vent has 1/4 inch mesh. Embers fly right through it into your attic, the largest continuous combustible space in your house. An ember-resistant vent has 1/8 inch mesh. It blocks 95% of embers. The cost difference? $15 to $30 per vent. $15. Wood siding versus fiber cement siding. Same torch, same flame. The wood ignites in seconds. The flame climbs. The char spreads. The fire is running. The fiber cement? It scorches. It discolors. It does not ignite. It does not propagate flame. It sits there and takes it. Ember-resistant vents, $150 to $300. Tempered glass on your most exposed windows, $1,000 to $2,000. Fiber cement siding on the most vulnerable wall, $1,500 to $3,000. Enclosed eaves, Zone 0 hardscape. The total cost to fireproof your home's most critical vulnerability points? Under $5,000. Under $5,000. The total cost to protect your home from the thing most likely to destroy it costs less than a bathroom renovation, less than a used car, less than a year of insurance premiums that you might not even be able to get anymore. And most people don't know these options exist, and the single most effective protection is free. It's called defensible space. 3 zones around your house. Zone 0, the first 5 feet, nothing combustible. Gravel, concrete, stone. No plants, no mulch, no wood. Zone 1, 5 to 30 feet, lean vegetation, trimmed low, nothing continuous. Zone 2, 30 to 100 feet, reduced fuel, spaced trees, managed ground cover. This is the same house. On the left, before, bushes against the wall, wood mulch touching the foundation, branches over the roof, dead leaves in the gutter. Every one of those is an invitation. On the right, after, gravel perimeter, trimmed vegetation, clear gutters. No fuel touching the house. This took 1 weekend and cost almost nothing. The data is not ambiguous. NIST, the National Institute of Standards and Technology, studied house survival rates in wildfire. Houses with no defensible space survive at below 5%. Add Zone 0, the 5-foot perimeter, and survival jumps to 30%. Add Zone 1, and it reaches 65%. All 3 zones, 85% survival, the same house, the same fire. The difference is the space around it. You don't need a contractor for Zone 0. You need a tape measure and a Saturday morning. 5 feet of gravel instead of mulch. Move the potted plants. Trim the bush that's touching the siding. Clean the gutters. This is the retrofit that costs nothing and changes everything. For new construction, the answer is even more definitive. Insulated concrete forms, ICF. Interlocking foam forms filled with reinforced concrete. The result is a 6-inch concrete wall with a 4-hour fire rating. 4 hours, not 4 minutes, 4 hours. Wood frame, 4 minutes to failure. ICF, 4 hours, and the fire gives up before the wall does. The concrete does not burn. The concrete does not carry flame. The concrete does not fail. And the cost difference, 10 to 15% more than wood frame for a wall that doesn't burn. Babcock Ranch, Florida, America's first solar-powered community. Built with concrete block walls, metal roofs, and fire-resistant landscaping. In 2022, Hurricane Ian, a Category 4 hurricane, hit Babcock Ranch. The community survived with minimal damage while surrounding areas were devastated. It was designed to survive. Babcock Ranch wasn't lucky. Babcock Ranch was engineered. Every design choice, the materials, the setbacks, the landscaping, the utilities, was made with the assumption that disaster would come. Not if, when. And when it came, the design held. Australia proved it at a national scale. Babcock Ranch proved it at a community scale. The surviving houses in Palisades proved it at an individual scale. The engineering exists, the materials exist, the knowledge exists. What doesn't exist is the requirement to use it. Australia mandatory standards for all homes within 2 years of Black Saturday. California, no mandatory retrofit for existing homes 7 years after Paradise. Still none after Palisades. The engineering is solved. The policy is not. If Chapter 7A had been applied retroactively, if every home in the Palisades had been required to meet the standard that existed since 2008, the survival rate would have been fundamentally different. Not slightly. Fundamentally. The code was right. The application was catastrophically incomplete. The insurance companies leave. The code doesn't apply. The houses keep burning. The same headlines. Year after year. Different address, same construction, same result. And the window is widening. Fire season in the western United States is 2 months longer than it was 50 years ago. Temperatures are higher. Droughts are longer. Vegetation is drier. The fire conditions are getting worse every year. And we're still building 4-minute houses into the zone. Right now, today, new housing developments are being built at the edge of wild land across the western United States. Wood frame, standard construction, meeting the minimum code, and the minimum code for existing homes doesn't require fire resistance. We're building the next Palisades right now. I've spent 3 weeks in the data. I've read the Australian standards. I've studied the survivors. And I've built a checklist, 5 things you can check on your house today, right now, before the next fire season. If you live within a mile of any vegetation, forest, grassland, chaparral, even an empty lot with dry weeds, the next 5 minutes could save your house. Check 1. Your vents. Walk around your house and look at every attic vent, every crawl space vent. If you can see through the mesh, if the holes are bigger than 1/8 of an inch, embers can get through. Replacement vents cost $15 to $30 each. 10 vents, $300 maximum. That's it. You can do this yourself. A drill, 4 screws, 5 minutes per vent. You don't need a contractor. You don't need a permit. You need a Saturday morning and $300. Check 2. Your eaves. Go outside and look up at the underside of your roof overhang. If you can see the rafter tails, if there are gaps between your siding and your roof line, that's an ember highway straight into your attic. Enclosed soffits seal that gap. Cost $500 to $1,000 for a typical house. Check 3. Your windows. Look at the corners of your window panes. Tempered glass has a small stamp etched into the glass. If your most exposed windows, the ones facing vegetation, are standard glass, they'll fail at 500 degrees. Tempered glass holds to 900. The upgrade costs $200 to $500 per window. Check 4. Your siding. What is your exterior wall covered with? If it's wood, it's fuel. If it's vinyl, it melts and exposes the wood sheathing beneath, which is also fuel. Fiber cement siding costs $8 to $12 per square foot installed. You don't have to do the whole house. Start with the wall facing the highest fire risk, the one closest to vegetation. Check 5. Zone 0. Walk the perimeter of your house. Is there anything combustible within 5 feet of your walls? Mulch? Dead plants? Firewood stacked against the house? A wooden fence attached to the structure. Anything within 5 feet is within ember range. Clear it. Replace wood mulch with gravel. Move the firewood pile. This one is free. 5 checks. 5 actions. Total cost for all 5, under $5,000. And that's not the cost to rebuild after a fire. That's the cost to prevent one. The total cost to fireproof your home's most vulnerable points, under $5,000. The cost of losing it, everything. Your house, your possessions, your family's safety, your memories. Everything you own in the world versus a weekend project and $5,000. The math is not complicated. This is what fire preparedness actually looks like. It's not dramatic. It's not expensive. It's a family spending a Saturday making choices about what their house is made of and what's around it. That's it. That's the difference between a house that survives and a house that disappears. Same house. Same neighborhood. Before and after. The aesthetic barely changes. The survival rate changes from 5% to 80%. That's not a renovation. That's engineering. But here's the hard truth. Your house doesn't exist in isolation. If your neighbor's house burns and it's 10 feet from yours, the radiant heat alone can ignite your walls even if you've done everything right. Fire preparedness works best when it's a neighborhood decision, not just an individual one. The FireWise USA program helps entire neighborhoods develop fire preparedness plans, community assessments, shared vegetation management, collective investment. When a whole neighborhood builds defensible space, the survival rate for every house in that neighborhood goes up, even the ones that haven't done individual retrofits. There are over 1,900 FireWise communities in the United States. Joining is free. The assessment is free. The Community Action Plan is developed with fire professionals. This is what organized fire resistance looks like at the neighborhood level. If you're building new, not retrofitting but starting from scratch, consider this. Steel frame costs 5 to 10% more than wood frame. It does not burn. It does not carry flame. Combined with fiber cement siding and a metal roof, you're building a house that fire cannot take from you. This is an ICF home after a wildfire in Colorado. Every neighbor is gone. This house has soot on the walls. The landscaping is ash, but the structure, zero damage. Zero. The fire burned around it and moved on. It couldn't get in. One house, built differently. While everything around it was designed to be affordable, this one was designed to survive. And it's standing in a graveyard of 4-minute houses. Last week, I showed you a house in Mexico Beach, Florida. An ICF house that survived a Category 5 hurricane while every house around it was destroyed. Same lesson. Different disaster. The house that was built differently survived. The ones that were built to be affordable didn't. I keep finding the same answer wherever I look. Earthquakes, hurricanes, wildfires. The house that survives is the house someone chose to build differently. Not the most expensive house, not the fanciest house. The house where someone asked, "What's the worst thing that can happen here?" And then they built for it. Think of fire protection in 3 tiers. Tier 1 is free. Defensible space, gutter cleaning, vegetation management. Tier 2 costs $500 to $5,000. Ember vents, enclosed eaves, tempered glass, Zone 0 hardscape. Tier 3 is a full retrofit, $30,000 to $50,000. Every tier improves your survival. But here's the critical thing. Tier 1 alone, the free tier, takes you from 5% to 30% survival. Free. The full retrofit, metal roof, fiber cement siding, tempered windows, ember vents, enclosed eaves, non-combustible deck, Zone 0 clearance, 30 to 50,000 for the complete package, under 5,000 for the critical points that stop most ignitions. Either way, it's a fraction of what you lose in a fire. And here's something most people don't know. Some insurance companies offer premium discounts of 5 to 15% for fire-hardened homes. If your annual premium is $8,000 and you save 15%, that's $1,200 a year. Your ember-resistant vents pay for themselves in 3 months. Your tempered glass upgrade pays for itself in 2 years. FEMA's Hazard Mitigation Grant Program covers up to 75% of eligible fire retrofit costs. California has multiple rebate programs. Many local fire departments offer free home assessments. The money is there. The programs exist. Most homeowners don't know about them because nobody tells them. Call your local fire department. Ask for a home wildfire risk assessment. Most departments do them for free. A trained assessor will walk your property, identify every vulnerability, and give you a prioritized list of fixes with cost estimates. Free. One phone call. I need you to hear this clearly. You do not need to rebuild your house. You do not need to spend $50,000. You need to do 5 things, 5 checks. And the most important one is free. Walk outside. Look at the 5 feet around your foundation. What do you see? That answer tells you everything. Zone 0. The first 5 feet around your house. It's the single most important factor in whether your house survives ember attack. And it costs nothing to create. Nothing. Move the mulch. Clear the debris. Replace with gravel. This weekend, California, Colorado, Texas, Oregon, same action, same result. Clear the 5 feet around your house. It takes an hour. It costs nothing. And it changes your house's fire survival odds from single digits to double digits. No permit required. No contractor needed. Just you and 1 hour. Every step matters. Every action compounds. Zone 0 alone takes you from 5 to 30%. Add ember vents, 50%. Add tempered glass, 65%. Full hardening, 85% and above. You don't have to do everything at once, but you have to start. And starting is free. Same fire, same wind, same ember density, same neighborhood. One house did the 5-point checklist, one didn't. 4 minutes later, one is gone. The other is standing. This is not theoretical. This is what the data shows. Every fire, every time. And do this. Call your insurance agent. Ask them 2 questions. 1. Do you offer premium discounts for fire hardening? 2. What specific improvements qualify? Get the list. Many of the 5-point checklist items qualify for discounts that help pay for themselves within a year. The checklist works. The retrofits work. The defensible space works. We know this because Australia proved it, because the Palisades survivors proved it, because every piece of data from every fire in the last 20 years proves it. The question is not whether the engineering works. The question is whether we're willing to use it. The American building system is optimized for one thing: affordability. The developer buys the cheapest land. The builder uses the cheapest materials. The code requires the cheapest acceptable standard. And the homeowner gets the cheapest house that's legal to build. Nobody in that chain is optimizing for fire survival, nobody. The difference is in the line items. $3.50 versus $6 for a stud. $2 versus $8 per square foot for siding. $300 extra per window. For a typical house, these add up to $30,000 to $45,000. That's the cost of survival. And the market decided decades ago that survival was optional. We've been here before. In the 1960s, the auto industry said safety features were too expensive. Seatbelts added cost, crumple zones added cost, airbags added cost. The federal government mandated them anyway. Deaths dropped 50%. Nobody today argues that seatbelts are too expensive. The argument sounds absurd. In 20 years, the argument that fire-resistant construction is too expensive will sound just as absurd. There are two futures. In one, we keep building 4-minute houses and losing them every fire season until entire communities become uninsurable and the property values collapse. In the other, we do what Australia did. We make the standard apply to everyone. We retrofit what exists. And we stop acting surprised when wood burns. Every house that gets built from this point forward is a choice. Wood frame or something better. 4 minutes or 4 hours. Affordable today or survivable tomorrow. That choice belongs to the buyer. But the information has to reach them first. And that's why I made this video. Last week, I showed you the glass floor. The point where engineering stops and cost-cutting begins. The point where the building code says good enough and physics says not even close. Fire finds the same floor. It just moves faster. The earthquake finds the glass floor in the foundation, the cripple wall, the unanchored mudsill. The fire finds the glass floor in the walls, the wood siding, the standard vent, the float glass window. Different disaster. Same fundamental problem. The code allows a house that cannot survive the thing most likely to hit it. 46 million homes. 1 in 3 American houses. Every one of them is a 4-minute house waiting for the wrong afternoon, the wrong wind, the wrong ember. 4 minutes, 4 minutes. That's the countdown. Not when the fire reaches your neighborhood, when the first ember touches your wall. 4 minutes from normal to nothing. Unless you change the wall, unless you change the vent, unless you clear the 5 feet. Then it's not 4 minutes. Then the timer stops. Under $5,000. 1 weekend. 5 checks. That's the difference between a 4-minute house and a house that's still standing when the fire moves on. The engineering is not a mystery. The materials are not exotic. The cost is not prohibitive. The only thing missing is the decision. I keep coming back to the Palisades, not to the fire, to the after, to the silence. 12,000 homes and the only sound now is the wind. And the wind has nothing to push against anymore. We build houses that burn in 4 minutes. And then we act surprised when they burn. We build them in fire zones. We build them out of fuel. We skip the vents and the glass and the siding that would save them. And then we stand in the ash and ask, how did this happen? It happened because we chose it. Not with malice, not with ignorance, with math. The math said wood was cheaper. The math said the code was enough. The math said the fire probably wouldn't come this year, and then the fire came. And the math was wrong. But not everywhere. Not every house. Because someone, somewhere in this neighborhood, made a different choice. They spent the money on the siding. They changed the vents. They cleared the 5 feet. And their house is still here. It's the only one. But it's here. Look at the evidence. The fire tried. You can see where the embers hit. The scorch marks on the siding. The soot on the vents. The ash on the gravel. The fire tried everything it had. And this house said no. One house. $5,000 in upgrades. Standing. 12,000 neighbors. Standard construction. Gone. That's not a statistic. That's a choice we made as a country. And it's a choice we can unmake. The fire doesn't destroy what's weak, it destroys what's normal, what's standard, what's code compliant, what's everywhere. The code allows a 4-minute house, and 4-minute houses are what we build. Until we decide to stop. This is the engineering story nobody told you. The embers that arrive first, the walls that burn in minutes, the code that protects new houses and abandons old ones, the country that solved it, and the 5 things you can do this weekend to make sure your house is still standing after the next fire. In the comments, I want to know one thing. How close is the nearest vegetation to your house? Not a guess. A measurement. Go outside. Bring a tape measure. Measure from your foundation to the nearest bush, tree, or dead vegetation. Put the number in the comments, because that number, that distance, is the difference between being the house that's still standing and being the foundation that's left behind. Between a 4-minute house and a house that outlasts the fire, the measurement is the beginning. Everything else follows from it. Build for the fire. Not for the brochure, not for the appraisal. For the worst day your house will ever face. That's not pessimism, that's engineering. Last week, the glass floor beneath your house. This week, the glass floor in your walls. The pattern is the same everywhere I look. Engineering has the answer. The code has the minimum. And the minimum is not enough. Next week, we go underground. Beneath your house, in the space you never look at, the space your home inspector spent 3 minutes in, there's a world of structural risk you've never seen. Moisture, settling, cracks, pests, the things that weaken your house from below, silently for decades. What's hiding in your crawl space is the thing nobody checks and everybody should, because the foundation you trust, the one holding everything above it, is it actually solid, or is it quietly failing? Next week on Built Into America Crawl Space. Subscribe so you don't miss it. Share this video with someone who lives near vegetation. They need to see it. And that measurement, the distance from your foundation to the nearest bush, put it in the comments. I read everyone. One house, still standing, still home, because someone built for the fire, not for the 4 minutes. The 4-minute house, built into America. If you live within a mile of wildland, go outside after this video. 5 feet, that's all. Clear the 5 feet. Everything starts there.
Next week, we go underground.